We're going to talk tonight about the SearchTaskGang case study. And this case study can be found at the link of the bottom of the slide. And the very first lesson here will explain what this case study is all about. It's basically about defining some subclasses that customize the TaskGang framework. We've actually talked about the TaskGang framework in a previous video series when we talked about the image TaskGang application. And we're going to have a new customization that will use different Java concurrency mechanisms to implement a so-called embarrassingly parallel application that concurrently searches for words in a list of input string objects. And you'll get a chance to see what this is all about in just a moment. So this is an overview of the class diagram for the key classes in this case study. I generated this class diagram using IntelliJ, the Ultimate Edition, I think it's called, where you can generate diagrams from code, which is very helpful. And these are a set of classes that show off a whole bunch of different Java executive framework mechanisms. And you can get the code here. The superclass, which is what we're going to talk about right after we give an overview of the test program, is part of a framework for spawning and running a so-called gang of tasks. Remember, gang in this context is not a pejorative term. It's like, a group of friends or things who work together to do something, like the Over the Hill Gang example I used from the Washington football team back in the 70s and 80s. What we're going to focus on first, however, is something that's called the SearchTaskGang test, which is a driver program that runs various specializations of the TaskGang framework to show off different Java executive framework capabilities. So here's what the class diagram looks like for SearchTaskGang test. And there's also a link to the source code here at the bottom of the slide, which of course you can get in my GitHub repository. And this example uses a customized version of the TaskGang framework to search for words in a list of string objects. And one of the things that this SearchTaskGang test class does is it defines an enum called tests to run. And you can see we have test to run, one-shot thread per task, one-shot executor service, one-shot executor service future, one-shot executor completion service, and so on and so forth. So let's talk about each of these different classes or capabilities associated with these enums. The one-shot thread per task is going to process a one-shot list of tasks via an executor that creates a Java virtual thread for each task. So the executor model is a thread per task model. Actually, it's a virtual thread per task. The unit of concurrency is a virtual thread for each of the input strings. So they're each processed separately by different virtual threads, which then get multiplexed over top of different underlying platform threads. And the results processing model is synchronous. We have the main thread wait for all the other threads to finish. So that's the first thing we're going to look at. We also have another example called the one-shot executor service. And this implementation processes a one-shot list of tasks using a fixed size pool of thread objects that are associated with an executor service that's also used as a barrier synchronizer. And so we're going to have a fixed size pool of threads as the executor model. We're going to have task for each input string be the unit of concurrency. And the result processing model will use a blocking queue that stores the results for intermediate concurrent processing. For immediate concurrent processing, not intermediate concurrent processing. And we'll see how that gets done using the mechanisms we'll talk about when we look at that implementation in more detail. There's yet another example called the one-shot executor service future. And this one processes a list of tasks using a variable size pool of thread objects using a so-called cached executor associated with an executor service. And it's going to also have a set of a list or queue of futures that are waiting the results to be finished. Its executor model is this variable sized or cached thread pool. The unit of concurrency is a little different here. Rather than being the input string, we're using a task for each of the search words. And the results processing model is a synchronous future model for deferred concurrent processing. And we'll see how that works when we look at that one. And then the fourth and final example here is called the one-shot executor completion service, which processes a one-shot list of tasks via a pool of work-stealing thread objects that are associated with the executor service. And here we have a so-called work-stealing thread pool. We have the units of concurrency being both a task per search word and a task per input string. And the result processing model is an asynchronous future model for immediate concurrent processing. And this is the one that really has the most concurrency relative to different examples we've looked at. So those are the four different implementations we're going to take a look at. Now, to make this all clean and easy to work with, our test program defines a factory method that creates the tests, and that's called make TaskGang. And it takes an array of strings that are the inputs and the test to run, and it creates the corresponding appropriate implementation based on the value of the enum. Notice how we're using the modern Java switch statement syntax, which is less tedious and error prone than doing the old-fashioned way with having to put breaks or returns at the end of each case. We also have a main method that iterates through all the tests and creates and runs them. So you can see here, we just iterate through all the enums, and for each one, we pass those into the make TaskGang factor method, and what we get back is an object that we then run. Something else just real quick, there's an option singleton. My programs typically have an option singleton. This implements the singleton pattern from the good old Gang of Four book. I'm not going to spend a lot of time on how singleton works. You probably know how that works. You can look it up if you don't. But I just want to draw your attention to two things. There are a pair of strings here, or actually arrays of strings. We have one-shot input strings, which are just a bunch of strings. We're going to search for the keywords. And then we have the word list that we've got, which is do, re, mi, fa, so, la, ti, and then o. And these are the words that are actually going to be looked up for all the tests. So I just put them in one place to kind of make it clean and easy to deal with. So what we're going to do now is we're going to take a quick look at that program. I've kind of walked through it at a high level, and let's take a look at the code. So here we are in the IntelliJ project for SearchTaskGang, and we're going to start by taking a look at the SearchTaskGang test. And you can see it's got that enum with all the different tests to run. The main program starts by taking any command line arguments and initializing the options singleton. We print a diagnostic, and then we go ahead and we iterate through all the tests. And you can see here, for each test, we're going to make the appropriate implementation and run it. And we do that by having this make TaskGang factor method that takes the array of strings and the test to run or test to create, and it goes ahead and creates the appropriate object here, returns this as a runnable because all these things inherit from runnable. And then when that's done, it goes ahead and runs them. Speaking of running, let's just go ahead and run this program. You can see what it does. And then we'll talk about the different examples later and see why they perform the way they do. So it's going to iterate through all the different test to run, and you can see here it prints out some information, and it indicates what thread ID a particular keyword was found in the input string, and it'll tell you precisely where this occurs. So you can see MI occurs here at offset 1, and here starting at offset 4. Down here you can see that we have OO appearing in a couple of places here, and these things are basically just repeated for each of the different implementations. And I think they should pretty much give the same results, maybe in a slightly different order, because it's concurrent after all, and therefore we have non-determinism. You can see that the thread IDs are printed out here, and they keep going up. Some of them could be reused if we're using pools, where we're using the one-shot thread per task. It's actually a virtual thread that's being created, not a pool of threads. And then down here, you can also see that we have the iteration count. All of these things are one-shot tests, so they all run only a single time. So that will always be 1. So that's the end of the discussion of the SearchTaskGang test driver program.